A trig function, can you remember what the general form of a trigonometric function is? So y equals sine or cosine, yeah. So a sine okay, because not only have we done trigonometric functions now and any functions, we have also, page 136 if you didn't hear me, we have also done what things with functions? Transformations of functions. So we are looking at applying our knowledge again to transformation of functions. So this should be a recap of the standard work as much as introducing the extended stuff of using radians. So what's the basic? We've got just y equals sine x, y equals cosine of x, and y equals tangent of x. We're going to focus on these two. All right. Got it? So if I said to you, I'm going to replace the y's with f of x, what have I got here? Regardless of radians or degrees. No, just in terms of function notation. What transformations have I got and how can I write it in function notation? So for instance, if I had f of x just was the sine of x plus d on its own, it would be f of x plus d. If I had f of x equals the 2 cosine x plus 3, that would be like doing okay. So what do I have? This one. Yeah, simple as that, isn't it? Yeah. So then I'm after, what do these things do? A applies, well, what does it do in, it's only amplitude in a trig function. So what does it do in general sense? Anyone else? Let everyone else have a think. What does multiplying by a do? Yeah.
A stretch.
Okay. Applies a stretch. Do you want to be more specific?
A stretch on the it would be y. Or, wait, yeah, because it's
in the y direction, like yeah. Because a gets done to the function, which changes which coordinates. It's outside the function, so it must have changed the y coordinates. So if I double f of x, I double all the y coordinates. So a applies a stretch in the y direction. I could say factor what? A. Yeah? Do you know what I mean by factor A?
No.
No? Everything is multiplied by A.
Okay.
So we can write that as all y coordinates are multiplied by A. The next one we could maybe consider, which would be what? Would I go B, C, or D next?
B. Okay, D.
I go with D just to explain D next. Because what does D do? Yeah, good. Applies a translation. How would I describe the translation?
Y-axis.
Yeah, could say it, but there's another way of doing it. I would actually write it. So a vector, wouldn't I? So translation of 0, D. So it is in the y direction. You're right.
Does that have to be in vector? Like, couldn't you just write it like regular coordinates?
No, because a coordinate is a point, whereas a vector is a amount of travel. Yeah. So 0D can be applied to every single point on your graph, whereas if I put 0, D as a coordinate, that's only one coordinate. It's not a movement, so it's about communication. So this is D units in the y direction, isn't it? Whether that is positive or negative, that's what we're saying. Okay, so the next thing to consider is, well, let's do B. What does B do? Let's have a think, Thibaut. What's B doing?
Is it a stretch in the X?
Stretching the X, isn't it? Yeah. Got it? Easy enough. So, B applies a stretch in the X direction. Factor what, Aisling?
It's 1 over B.
Good. 1 over B. Yeah? Do you remember that? Because when I do things to the x coordinates, it's kind of like the other way. So that means that all x coordinates are multiplied by 1 over B, or divided by B. But I can't say divided by B as a factor. A factor is something that you multiply by. All right? And then, of course, you get the idea of the last one.
Yes.
What does the last one do, Nick?
It's translation on the x-axis.
Yeah. So a translation, and what would the vector be? Yeah,
It would be c over 0.
would be c over 0, you think? Anyone disagree? Negative c, isn't it? Remember, it's the opposite direction, what c is. Right. All right, so we've got all that down. We know our transformations. We know how to apply it using function notation. So then it's a case of knowing how to sketch our original curves for sine and cosine to start with. All right. You have to do it in degrees. You lot have to do it in degrees or in radians, whichever one matters. So let's start by doing it in degrees. Let's do. If I were to ask you So we'll do it together first. So you can just put your pens down a sec. We'll talk about it. If I asked you to sketch the curve of just y equals sine x first, what would you do? What would be your process? Greg?
I would make a point at 0, 0.
Point here, okay.
Then I would make a point at 180.
Point at 180. So I'm going to go maybe 3, 3, 3. So 180 maybe here. 180 there. Then I'm going to have 360 there. Okay.
And then, what does it go up to?
Yeah, what's it go up to, Nick?
1.
Goes up to 1, doesn't it? So what I might actually do here, look, is I've told you before about putting in a little dotted line. Okay.
And the 90 is
And also down to -1, isn't it? Right? So sine goes up to 1 and down to -1. We've got 0 in the middle. So, does it go up first, down first? What?
It starts going down
From?
the origin.
Sure? So it goes down.
I do believe. Or would that be negative sine x? I'll stick to my gut and say it goes down.
So that should be 90, that should be 270. So it actually goes up. So sine of 90 is 1. Do you know how I know it goes up? What were we doing last lesson?
Oh, with the circles.
The circles.
It's positive first.
It's positive
before it goes
first,
to
isn't it?
negative.
Yeah, exactly. So you start at that point. If I go anywhere up to 90 degrees, sine and cosine are both positive. Look. So sine is positive whatever it is. That's sine of x. And this distance here is cosine of x. And they're both positive. And cosine gets bigger or smaller as I move to 90 degrees. Smaller. But sine gets larger. So actually, sine should go up. Sine comes back down. Sine goes into negatives. Sine goes back up to where it started. So my sine curve, right, that was a rubbish start. So my sine curve should go up. Nice rounded curve. Okay. So there's my sine curve. What should those values be, extended, if I'm going to work in radians? And 2 pi. Okay, so now if I asked you to do, all right, notice I've only done between 0 and 360 here. What happens the other side? Goes up again and down?
No,
Goes down.
Yeah, goes down. Right, okay. Now if I asked you to sketch, well, so Ethan, if I said to you, you can do this one first and then show me what a sketch of 2 sine, let's say, x plus 30 plus 1 would look like. Okay? And extendeds, yours is going to look a bit more like y equals, let's do -2 sine, but this time we're going to have x plus
3.
Let's do pi over 2 plus 2. Okay? So you got 1 in degrees, 1 in radians. What are they going to look like?
along those